Let's see. There we go. Cool. So we're live on YouTube too. Sorry for the hiccup. Definitely my bad. So again, thanks for joining today's webinar. Really nice to have all of you here, and look forward to your questions. We'll talk about mastering Terraform automation and collaboration with GitHub Actions. I'm gonna show you a little bit what we've been working on in the past couple of weeks and months here, and I'll start by explaining some slides, and then we'll jump into a demo. The demo is also available on GitHub, so whenever you want to see how we think about those things, you can always check it out after the webinar. I'll make sure to share it on LinkedIn and Twitter too. Again, I'm Soren, one of the founders of Terramate, very active in the Terraform and OpenTofu community. And let's dive right in. So, infrastructure as code introduces a bunch of challenges, and I guess that a lot of you guys will be aware of this, as you probably manage cloud infrastructure with Terraform, OpenTofu, Polumni, or whatnot, right? But to talk about this a little bit more. So, what are those challenges? There's different problems to solve, and to mention some of those, orchestration. Orchestration basically means now that you have multiple Terraform root modules, which we call stacks, you probably want to be able to decide whatever of those modules are deployed in a pull request inside your pipelines. Yeah, then it's a whole automation. So you would be surprised how many people still invoke Terraform locally to roll out to production. Whereas I think we can all agree on the fact that instead of doing that, we should, really go through a pipeline and through a pull request workflow, which brings me to the next point, GitOps. So um, GitOps basically means that yeah, instead of doing this locally or following whatever process, what we really want to do is we want to open a pull request that introduce a bunch of changes. We may want some peers to review this. We might even want to run some static code analysis on this or some tests or whatnot that guarantee that whatever we change here is sane, secure, and integer. And I'm also showcase how to do this. Dryness in Terraform is a big topic. Tools such as Terragrant have been around forever to solve this. Terramate does this too. So the two projects differ a bit, but both are great projects, I believe. So dry basically means do not repeat yourself. In Terraform by nature is a lot of code duplication, which you most likely want to avoid. Otherwise, you build up this big pile of config sprawl. It becomes unmaintainable over time, etc. Drift control. So drift control means infrastructure drift is basically whenever your configuration, so your Terraform configuration, drifts away from whatever state is deployed in your cloud infrastructure. So that could mean, let's say you have a database that automatically scales up or down. So now if that happens, let's say the hard drive of your database scales horizontally, it would basically cause a drift in our infrastructure code, right? It means the current configuration does not represent whatever is deployed in my cloud accounts anymore, and that should be prevented. DevSecOps is to understand, okay, so things such as static code analysis, is my code secure? Do I follow best practices? And here we have bunch of toolings available in the market, TFSec, TerraScan, Checkoff, and then also enterprise-centric kind of vendors. Wiz.io, I think, is one of the vendors that recently started supporting remediations of security and threats directly in code. So that's interesting. Observability. And observability basically means to understand, okay, whatever has deployed at a certain point of time, is if deployments failed, how drift develops over time, those kind of things. So we'll look into this too. Dependency management means, updating and managing versions of providers, Terraform versions, modules, and whatnot. Self-service and best practices, a little bit more of an advanced topic. So how can we basically transform Terraform into something that is understandable by developers. And to solve those issues, there's always two different approaches. Either you start building a platform yourself, so you have a dedicated product team that basically starts solving those problems by gluing together a bunch of heterogeneous tools, or you start buying a purpose-built CI/CD platform that are pretty expensive and often also cumbersome to onboard and manage. So what I'm saying is that those platforms are not bad. Quite the opposite. Often they have decent and good products to offer. But it basically requires you to shift from ever you have already towards a centralized platform, and you need to provide them with access to your state and to your cloud accounts. And it may not be for everybody, right? So while those platforms may be good for some folks of you, this decision should really be taken on your own. What we believe here at Terramate is that, hey, most likely you don't need to buy a purpose-built CI/CD. And the reason for that is because you already have one. You already have a CI/CD, and that is GitHub Actions or GitLab CI/CD or Bitbucket, or maybe you orchestrate and deploy Terraform from inside Kubernetes or whatnot. Yeah. So it's always the same scenario that I see here, that whenever we shift to purpose-built CI/CD, it sort of introduces a change in paradigm of how we use tools, and it requires quite some effort, right? And it not necessarily serves everybody in the company. So again, I believe, or we believe that for a lot of you guys, it's going to be totally fine to run on GitHub Actions and to basically use capabilities that you have already. So those would be compute, so reusing GitHub Actions workflows, asynchronous job queues, those kind of things. Security already in place, so you can use OIDC to authenticate from GitHub Actions with short-living credentials, and to AWS, to Google Cloud, and whatnot. You also have things such as, access management, workflows, even logs are there, right? So all of this is quite good and pretty advanced. And if you look at the market, I think GitHub Actions, I started using GitHub Actions since day one, and man, it was such an premature kind of product, but it became so good over the past couple of years. And essentially, the interface and the reliability and the underlying scheduler of GitHub Actions improved so much, especially since we have the GitHub Actions marketplace, right, which gives us lots of access, to lots of pre-configured GitHub Actions that you can just reuse and run. So what is required to automate and orchestrate Terraform on GitHub Actions? That's a good question. So there's different things. Orchestration is required. And orchestration is something that it's hard to do natively in GitHub Actions. So that basically, orchestration basically means, hey, we want to be able to orchestrate a bunch of Terraform modules, oftentimes in parallel, oftentimes by opening and managing multiple pull requests that touch different parts of our code base. And the reason for that is that in Terraform, often you want to split up your state, right? You want to split up your state, and instead of managing everything in the central and big ever-growing Terraform root module, you basically introduce something that we call stacks. I know that Terraform, folks over Terraform are working on a native concept of stacks. Looks quite cool, but unfortunately only available in Terraform Cloud and Terraform Enterprise. However, I think in the industry is common understanding that what a stack actually describes as of today is a Terraform module that manages and contains a state, so groups together a bunch of infrastructure resources that can be managed isolated as an isolated unit. And that's the whole automation part. So automation basically means the CI and the CD part, automating the lifecycle management here of Terraform. Collaboration then means like, oh, we probably want to be able to collaborate on changes and maybe even ask our colleagues whenever they introduce a change, hey, this may not be so suitable to what we really want, so please change line ABC. And then observability. And observability is a topic that is wild and wide in infrastructure as code because it differs to observability in application lifecycle. So here, observability is more about what deployments ran successfully, what deployments failed, how does my drift develop over time? So and the way that we can basically achieve this is by using a few toolings, but then heavily built around GitHub Actions. So for the orchestration part, there's several tools that exist in the market. I think the most popular, and I'm gonna say this in the right order because Terragrant is a lot more popular than Terramate still. So Terragrant, I think, is the most well-known tool in the market. And then there's Terramate, and there's a few other rather small ones like Atmos, I think, which also seems to be a decent tool. Haven't really used it, but might be worth checking out. And then TerraSpace, I think, is another one. So for the automation part, we want to use GitHub Actions, of course. Collaboration then would be done GitOps via pull request, and I'll showcase how to do this in a second by going, showing you how to basically write a bunch of code here, open a pull request in GitHub Actions, and how to provide plan previews here so we can review this, and then observability. Whereas observability is something where we build a Terramate, we build a product around it. So there's different ways of achieving this. The very basic form of observability you basically find in GitHub Actions by looking at the deployment runs, right? But if you've managed, if you ran on GitHub Actions with a fairly decently sized team, it becomes quite messy over time, and it's quite hard to understand who actually introduced what changes, what deployments failed. Unfortunately, deployments fail in Terraform all the time because of misconfigurations or networking errors or whatnot. So brings me to my next point. I think how Terramate fits in here is so we think about Terramate as sort of a next generation infrastructure as code management platform. Right now, we focus on Terraform and OpenTofu exclusively, but we will add support for Pulumi and even Kubernetes native deployments in the near future. So we want to turn this more into a developer kind of centric platform. But what Terramate really is as of today, it's an infrastructure as code management platform that runs natively in any CI/CD, and it's quite important because it means that Terramate never has any access to your state, never has any access to your cloud accounts or to your code. And so it makes it secure, it makes it efficient to use. And a lot of the value that you can get here really is also in the open source. So if you're a small team or just a bunch of developers or even a single developer, you don't really need to buy any purpose-built CI/CD here. So now, what is the two components that we will look at today? So basically, we do have an open source CLI called Terramate CLI, and Terramate CLI basically helps you to create, manage, and orchestrate stacks locally or in any CI/CD, right? And it's meant to be used by individual DevOps engineers, smaller teams, to become more productive, to automate and Terraform and whatnot. And then there's Terramate Cloud. Terramate Cloud is a product that we're building. So it actually went public. So we opened up registration not that long ago, a couple of days ago. Yeah, we keep building it. There's a bunch of great things to come that we won't talk about today. So it's not a product pitch, but basically what we look at here is we look at features for collaboration, observability, drift control, and deployment workflows, right? And it's really meant to be used by DevOps teams and to collaborate better and deliver more value to their internal customers, which are most likely always developers, right? So let's look a little bit into how we think about this here. And I'll guide you a little bit through code and I basically created this architecture here before, and it's in a repository located in github.com, Terramate.io, GitHub Quick Start, Terramate Quick Start AWS. So let me close the presentation, and then let's look at this repository. So what this really is, this is a reference architecture that uses, as of today, I think Terraform 1.8, so the latest version, and Terramate, as well as GitHub Actions, to manage cloud infrastructure with Terraform, and the whole automation here is basically done in GitHub Actions. You can check this out. You can clone this, fork this, play around with it yourself. So it's connected to an AWS account of ours, so we can actually deploy stuff in here. We manage the state on S3 for this specific example, and let's dive right in. Yeah. So what is required for me to basically introduce changes here? Yeah. What I want to show you is to, basically add a bunch of infrastructure resources, maybe just use a null resource to keep the coding effort here as small as possible. And then we look at how this looks like from a workflow point of view. So what you can see in this repository, we have a bunch of files and a bunch of directories here. And basically, there's a few GitHub Actions workflows here that you can find in this repository and also in our documentation, and they help you to get up and running with Terraform automation on GitHub. And for us to start, what I'm going to do is I'm just going to create a stack in Terramate. And I call this a webinar stack. So in Terramate, we can basically create a new stack by saying, hey, Terramate create stacks, and then we call this webinar. So we have this stacks directory here. There's a VPC stack in here, which is basically just an example on how to deploy in VPC on AWS. We'll give this a name, and we'll also give this a description. This is an awesome webinar, something like that. So let's run this. What's going to happen here is basically you can see that we have a new directory here, and this directory contains a stack. So the stack.tm.htl describes a stack in Terramate CLI. We use HashiCorp configuration language here to basically configure stacks. And the nice thing here is if I introduce an error here by introducing a typo in the stack, you can see that the IDE gives me feedback. So whenever you install Terramate CLI, it basically distributes with two binaries. The CLI that you use to deploy, orchestrate, manage Terraform and Terramate stacks, but also language server. And the language server comes with IDE integrations for VS Code and Vim, and helps you to write Terramate specific configuration by having feedback in the IDE. What's funny is that I recently noticed that Copilot picked this up too. So there's Copilot suggestions now for Terramate syntax, which was great to see. You can also see that we basically have a backend.tf here and a terraform.tf, which declares this directory as an isolated Terraform environment, right? So you can see here, okay, this is generated by Terramate. The way that this works basically in Terramate, Terramate always generates native Terraform code, right? So compared to other tooling in the market, the way that we think about it is like, hey, Terramate CLI should be an optional tool that helps you to become more efficient whenever writing and managing Terraform code. But we don't want you to shift from a native Terraform environment toward any other syntax. So that's the reason why whatever you do with Terramate always defaults and ends up to native Terraform code. And it's quite important for us because it means that you can easily integrate this with all other tooling. Yeah? So you can basically use Terramate CLI and then run on any other platform that supports native Terraform. Whether that would be a platform that helps you to keep your code secure, or even purpose-built CI/CD. So and also integrates with all other tooling in the market without us needing to basically come up with purpose-built integrations for those. So that's quite nice, and it's a big difference to TerraGrant here. you can see that, so we have those files here generated, the Terraform configuration, which has the AWS provider, the backend configuration. I don't want to go too much into the details, but just to show you quickly how this works. So in Terramate, we have this language based on files that are called .tm.hcl. So what this basically does is it says like, hey, generate an HCL file that we call backend.tf. And in every single stack, so we can have conditions here too, but we don't need this in this specific case because we just want to have this added to every single Terramate stack here. And then we say, hey, give this content, and the content should be the backend configuration for Terraform. And then we use language constructs here in Terramate, such as globals, which are a nice way of declaring data. Declaring data once. So for example, here we say, oh, globals Terraform backend. So we can declare the buckets here used for the backend, Terraform versions and whatnot, and it's going to be reused inside this code generation. But also too, you can override, extend, inherited this and any in any level of your stack directory tree. All right, so let's go on. I'm gonna add a main.tf here, and let's ask Copilot to please add, I like to ask the AI stuff with please. So please add a null resource here called Terraform, null resource called webinar example without the backend and provider configuration because we already have that. Let's see what this comes up with. All right, so let's accept this. It's just a null resource here. This looks good. So what we've done now is basically as a stack, so a Terraform, isolated Terraform module that we can deploy, manage as a single unit. And then we added a null resource here. So it has state, not any specific resources, just a null resource to understand here. What I will do next is I will basically create a new branch and I call this webinar demo. So now let me check how Git looks here. And we can see already that my Git is clean as this new stack that I now want to add here. So let's do this. Git add, Git commit, add webinar, add a stack for demo during our awesome webinar. So what's happening here is that the repository basically ships with a few pre-commit hooks. So for us to understand, like, hey, is the code properly formatted and is it well configured? We basically run those pre-commit hooks here on pre-commit, so you spot any misconfiguration before actually opening up a pull request. Next thing we will do here is basically say, okay, git push origin webinar demo. All right, let's open up a pull request. I can just basically go in here, compare pull request, open up a pull request, and this is it. So what's happening now is that if we look here at the workflows provided with this demo, we basically have three different workflows here. We have a work previews, we have a workflow for deploys, and we have a workflow for drift detection. And the way that this works is in the preview, we'll see this in a second, basically what Terramate does here now. Terramate CLI runs on GitHub Actions and detects a list of all stacks that contain changes within this specific pull request. And it's quite interesting because if we look at the CLI here, we can basically say, hey, Terramate list. So it shows me a list of all stacks, and you can see that we have some multiple stacks managed here. But now if I want to see a list of stacks that have just changed, I can append this change flag here. And what Terramate does in the backend is to basically look at the range of commits from this specific branch compared to the main branch, and then it understands what of our stacks here have actually code changes introduced. But not only that, also does Terramate understand dependencies in stacks and module calls and whatnot to also understand deeply nested changes. Let's go back to this pull request. So this still runs. Oh, there's an error. What's happening here? Let's see. Oh, interesting. There's an unsupported Terraform version. I guess I haven't updated Terraform here. So let's do this. Interesting enough, I upgraded Terraform in the repository to version 1.8.0 before, but I forgot to update the required version in Terraform. So what I'm doing here is basically I update this global. And now, you know what? Let's actually not do this. Let's actually downgrade this to version 1.7.5. And let's just add this here. So we're on the right version because we installed a version here from a package manager called ASDF. So I'm going to do this. Downgrade Terraform to version 1.7.5. I'm going to push this to the branch with git push. And now the pull request should run. Sorry for that. Should have tested better before the webinar. Okay, so again, what happens here is since we push a new commit, Terramate, so GitHub Actions will pick up this new commit and will run the pipeline again. Yeah, and now Terramate should be able to basically give us a list of changed stacks, and feedback this inside of a pull request here in a second. So let's look at this. Wait a bit. Can take a look at the pipeline too. So what's happening here in the pipeline is basically what we do is we install Terramate and then we install Terraform. We check formatting here once again, and we take a look at the changed stacks. You can see, oh, only this webinar stack has changed. We configure the connectivity to AWS, and then we initialize Terraform within this changed stack, and we basically run a plan. And if we look at this now, what's viewable here is that you can see, okay, Terramate with GitHub Actions, so there's no magic. What we do is we basically say, hey, Terramate, run this plan for us. So this is the orchestration. The orchestration detects whatever stacks have changed, and it only runs Terraform plan within this specific stack. And we can see this here by saying, hey, Terramate enters the stacks webinar, and now it runs and the show command in here after it ran the plan. And we can see, okay, cool. So the change introduced here is basically in our resource. So let's go back to our file here and let's just add another one of those. We call this another webinar example. Okay, so I introduce another change. Git status. I add this again. We call this add another resource. By the way, you should be able to see this in the repository too if you follow this. So let's push and see what happens. Again, the automation should pick this up as a change. So while this runs, you can see there's a link to Terramate Cloud. And that's something that we do optionally here. Terramate Cloud is our newest product. Mentioned it early on in the webinar. And what's interesting is let's look at this workflow here, and let's look how Terramate basically invokes those commands. So what we're saying here, and I hope this is big enough for you guys to see. Please let me know if not. But basically what we're saying here is we say, hey, Terramate run a command in all stacks that it finds in the directory stack. So with -c, we basically saying, hey, change your working directory to stacks, run a command in all stacks that are inside there in parallel. So Terramate has multi-threading or parallelism. So we say, hey, run this in parallel with 5 threads. And Terramate will detect, any stacks that are dependent on each other and only execute those sequentially. So there's no race conditions or so. And then we say, filter this by only select change stacks. And then run this command Terraform plan, right? But also the plan that is generated here, sync this to Terramate Cloud. So now if we look at the cloud here, and this is in dashboard here in Terramate Cloud, it gives us an overview of all stacks managed across multiple repositories. It's a demo organization. It's not so much going on here, but you can basically see, oh, we have 55 healthy stacks. 2 are failed and 1 is drifted. We see last deployments here, last failed deployments here. So now for me to basically go in the pull request hub here, I can see, oh, there is a pull request open in Terramate Cloud, in GitHub, that there's a review required. And if I look at this, I can see, okay, this is the plan. And those are the logs here that are associated with the specific plan. So it's synced from GitHub Actions to Terramate Cloud. Cool. Let's do another thing. We create a new stack. Terramate, create stacks. Let's just call this webinar 2 or webinar B, webinar stack 2. Let's create this, and we add a bunch of resources in here too. So you can basically just honestly copy paste the code, because this is an isolated Terraform state here. We can basically just deploy the same resource again. It won't matter because it's a different Terraform, a different state file, in a different key within the specific state, right? So that's quite nice here. If you look at this specific key that we use here to identify the state in S3, this is the Terramate stack ID. So if you look at this, Terramate comes with a unique ID per stack. And then we use this in a code generation to create the state reference here. And the nice thing is, because we don't depend on the path or so, you can look into this here. So we say like, hey, the key should be the Terramate stack ID. So it goes into every stack, generates the file in there, and then it uses the stack ID to basically reference the correct state path. And because we do it this way, it basically allows us to move stacks up and down the directory tree, right? Okay, so without breaking the state ever. Git status. And now we add this stack 2. Let's add another stack. And I push this to the same branch. Awesome. Let's go back to our pull request here to understand what's going on. So as you can see, what this GitHub Actions is doing now, by the way, we have all those workflows here available in our documentation. So those are just like pre-configured workflows you can use to easily get up and running on GitHub Actions. But what this workflow is doing now, it basically understands, hey, there's a new commit. And the plan that I've generated previously is not valid anymore. Hence, wipe this command, wipe this plan, wipe this comment, and create a new one. So Terramate orchestrates Terraform again on all change stacks. And once this goes through here, you can see like, oh, now we not only have 1 stack that has changed, but 2. And it basically gives you an output of those both stacks, right? So now if I go back to the cloud here and I refresh the specific pull request, we can see like, oh, cool. So in our stack browser here, we can see basically 2 stacks that have changed, the resource that I deployed here, and we can switch and jump to the log lines too. All right, so in Terraform, on GitOps principle, there's always ever 2 ways on how you want to roll out changes. One way is by basically saying, I want to have something like Terramate apply, based on a comment. So that would mean that's a commonly used pattern in tools such as Atlantis or Digger Dev does that too. So basically saying like, hey, you want to deploy changes inside of a pull request. That is called apply and merge. However, if you really want to follow GitHub principles, our philosophy here is mostly to run merge and apply. So we merge a pull request back to main, and then we roll out changes. There's different pros and cons to both processes. Obviously, if you were to run apply within a single branch, you can make sure that the change actually gets deployed before merging back to main. But it also introduces complexity. Now you need to understand that oh, do I change some code in multiple pull requests, and can those changes override each other? So there needs to be mechanisms implemented such as locks on specific stacks or pull requests. And it's doable. You can do this with Terramate too. However, the easier, more straightforward process is to just, merge back to main, apply the recent commit on main, and if something fails, yeah, if you want to if you want to follow GitHub's principle here, you obviously just open up a new branch and a new pull request and come up with a fix. So normally what we would do now is people would review this. Yeah, people would review this change. But unfortunately, I'm on my own here today, so I'm just gonna use my admin superpowers, um, which is bad, by the way. Plan should be reviewed by a peer. In infrastructure deployments, it's always the same. If we roll out something that's destructive, it usually things go wrong really bad. But I'm just gonna do this now. There's no tough changes here. So let's merge this back to main. And now if we look at the actions, what you can see is like, okay, so now this Terraform deployment action here triggers. And if you look at this workflow, this again just runs natively in your CI/CD. So we're saying here basically this is two things that that we do. We say like, hey, okay, so apply plan changes on change stacks. And again, we say, hey, Terramate run. So Terramate run a command in all stacks that you find in the directory stacks that contain changes, and then run this, sync this to Terramate Cloud and run the command Terraform apply, and then basically apply a plan that was previously generated here. And the nice thing about this is that basically Terramate syncs this data to Terramate Cloud. Is optional, right? You can remove this and then you're fine with the open source. But it gives us a good understanding of what happens here and if a deployment fails and whatnot. So what Terramate really does is it looks at the plan file, it removes all sensitive values such as secrets and whatnot, and then it pushes this plan to Terramate Cloud. So if you look at this, you can see there's a new deployment here in Terramate Cloud. So this ran successfully. Yeah. And it basically just took 40 seconds. We can see there's two stacks affected here. So if I look at this, we can see the stacks. What's coming here soon is so resources, what specific resources have changed and activities. So you can, collaborate on this in Terramate Cloud. We haven't built this yet, but it's on the way. And basically understand like, okay, so what was the plan here? How does the log files look like? Okay, so this was obviously applied successfully. And then we have health checks. And health checks are interesting because what we do is we say like, hey, whenever you roll something out, you should probably do a drift check right after. So with this specific workflow, we do a drift detection by running a Terraform plan right after an apply to detect if specific configuration has drifted right away. That also can happen all the time. So what else? If we look here at the stack list, you can see already in this specific dashboard here. So that's a demo organization which is linked to this specific repository that we're using here. So that's at Terramate.io, Terramate Quickstart, AWS. This dashboard shows us basically, we mentioned that, stacks managed, how many of those are failed, how many of those have drifted, a nice overview here, and then failed deployments. But we can look at the specific stack list here too. And what you can see already is like, this is coming from multiple repositories. So if you're an organization that grows to some extent, most likely you will not manage Terraform anymore in a mono repository, but you will fan out to multiple repositories, right? And the pattern that we see here already is that, okay, all the time is basically often there's a centralized repository to manage like basic kind of infrastructure that is shared among multiple teams, such as a landing zone or whatnot. But then people tend to move application related infrastructure to the application repositories. And here we can see, okay, so we have a drifted stack. Let's filter this. And we can obviously also filter here by repository. So this is a TerraGrunt example of ours. Terramate integrates well with TerraGrunt 2. So you can use this to, orchestrate TerraGrunt modules and add things such as the automation workflows to TerraGrunt, drift detection, but also change detection. So in TerraGrunt, you only always can apply one or multiple modules. If you add Terramate to TerraGrunt, you can basically have things such as the change detection to detect what stacks have changed here. And if we look at this drift, that's interesting. So we basically see that there's a drift occurring in this specific stack. And what you can see here is, okay, so this is a stack that is coming from the Terramate Terragrant infrastructure live example, which is another example repository of us. So this is the Terragrant reference architecture that we forked, and then we added Terramate to it. And what you can see here is a Terragrant configuration, and this Terragrant configuration says, hey, the allocated storage of this MySQL database should be 120 gigabyte, but it didn't deploy. So the detected storage here is 40. So, and it drifts, right? And the reason for that is because when this was rolled out, I think the database was configured to only apply this change within the maintenance window. Bumps, your infrastructure code is drifted. What we can also see here is the latest deployments. So whenever this stack was deployed, as well as the latest drift runs. And that brings me to the last point. The way that we think about drift runs at the moment, so basically, if we look here at this workflow, so this is a similar workflows for the demo as well as for TerraGrunt. Let's look back at the demo repository. So what we're saying here, we say like, hey, run a drift detection every 30 minutes, okay? And then what it does is it basically creates Terraform plans here, and it syncs, if there's any detected drift, it syncs it as a specific, as a drift to Terramate Cloud, right? And that's the reason why in this specific repository, we can see that there's a drift here and when did it run. So if we look back on this repository, you can see in here, okay, drift detection reconciliation runs here, and it syncs the data basically back to a Terramate Cloud for us then to review the drift to send alerts. So those can also be sent to Slack and whatever messaging of your choice. So you have a nice overview of like, oh, drift occurs. And what is most interesting here is we can basically reconcile drift in with Terramate very easily. Let's look at this repository here. And we do this by basically saying, okay, if we look at this workflow, this is the part that detects the drift, right? And here we can say, okay, Terramate run on all stacks that have drifted and that have a tag reconciled. So you can conditionally say whether or not a stack should be reconciled, and then run TerraGrunt apply. Yeah. So if we go to this repository here, let me open this up. It's this repository. We don't save these changes for now. So let me just check out the main branch here real quick. So now we already learned that with language servers connected here with Terramate list, we can see a list of all stacks, right? So now what I can do with Terramate, I can basically log in to the cloud. So let me do this. I'm just quickly pulling this this window in here. So we support different identity providers. I'm using Google Cloud here, Google Workspaces. Let me look into my Terramate account. Doing this, thanks for signing in. Yeah, awesome. And now the CLI says, feedbacks me like, hey, cool, you logged in as Terramate authentication successfully. So now what does it mean? I can now use the CLI to query Terramate Cloud. So what I can say is, okay, Terramate list gives me a list of all stacks. Terramate list cloud status changed gives me a list of all cloud status drifted, gives me a list of all drifted stacks. And if you look at the stack here, prod US East 1, prod MySQL, if I look back at the cloud, this is exactly this specific stack here, right? So we can use data, we can use the cloud to basically sync and query data and get a state machine about our stacks and use this to reconcile drift and whatnot. Yeah. So what I was showing here is that basically Um, Terramate Cloud takes care of the observability collaboration part. I think you can use GitHub Actions only too. It's of course a commercial product of ours, but I wanted to show you how how we've built this, how we think about persisting state, about stacks, and making sure that folks can understand here what's going on. But in any case, you're totally fine for previews and for deployments to use the GitHub workflows here, right? So you can just go through pull request. You can use GitHub principles to review and deploy changes, and there's oftentimes no need for purpose-built platform, right? Where purpose-built platforms really shine is for more advanced patterns, such as, let's say, you want a module registry, like a proprietary module registry or so. This is something where those platforms are typically helpful. Um, this is it as of the content shown today. Just a few more links here. Let me share my screen once again. Share screen. Here we go. So yeah, if you want to give Terramate CLI a spin, take a look at github.com Terramate IO Terramate. With pretty good documentation, getting started guides here. What's exciting is that you can onboard Terramate to any Terragrant environment, to any Terraform environment, to any Open Tofu environment with a single command. So that would be, we can look at the docs here real quick. If you look at our documentation, we have guides for start with Terraform, start with Terragrant, start with Open Tofu. And basically, you can do this by using a single command. So here, this would be Terramate create all Terraform. It just creates stack files inside of your Terraform root modules without changing any configuration. And you can use all those features, such as the orchestration, change detection, and whatnot. So the onboarding is really nice, straightforward, and seamless. And in fact, you don't need to refactor anything, any configuration to get started with Terramate here. There's also the cloud. So if you want to give the cloud a spin, you can sign up for a free cloud account at cloud.terramate.io. We just open up the cloud and it's available to be used now. So feel free to give this a spin. And then if you have any questions or if you have any questions regarding, Terraform, GitHub Actions or whatnot, you can always reach me in Discord. So we have a public Discord community at terramate.io and then /Discord. And I'll be more than happy, as well as our team, to answer all your questions. Thank you so much. That's it as of today. Let me know if you have any questions. I'm going to be here for a couple more minutes. Would love to hear questions, some feedback. Did you like what you've seen? And then we can take it from there. All right. So there's one question regarding Terragrant. Okay. So probably that was missed. So does Terramate integrate with Terragrant, and how does the onboarding process look like? And the answer here is yes. So we don't view ourselves as a replacement for whatever tooling you have already. So if you use Terragrant, that's totally fine. Terragrant is a great tool. But again, I think it lacks some capabilities, such as the orchestration behavior, change detection. So for you to get started here with Terragrant, we basically have this single command onboarding, which I just showed. So it's in the documentation. Start with Terragrant. You can use this with a single command, and you have those capabilities. Basically, what that means is that Terramate is an orchestrator that can orchestrate all sorts of tooling. So we don't wrap around Terraform or OpenTofu. In fact, you can orchestrate whatever command. You could orchestrate infracost in stacks. You could orchestrate checkoff in stacks, and really any other binary that is executable here. And also sync the outputs of the results of those tools to Terramate Cloud, of course. Is Terramate Cloud a free product? Yeah, so Terramate Cloud is free to use as of now. We'll have plans for teams and advanced features. If you want to get started, really just sign up for a free account. The onboarding doesn't take longer than 5 minutes, and you can give this a go. Would love to hear your feedback on that. Would love to learn what you guys think about it. In any case, if there's any questions, just join our Discord at terramate.io/Discord. So I'm around there all the time. More than happy to help. All right. So for now, it doesn't look like we have any additional questions. Here's still 27 people in the call. Well, then I'd like to say thanks. Thanks for tuning in. It was great talking to you guys. And oh, there's another question. How would these Terraform features work with different tooling, such say different CI tools such as Jenkins, Circus CI, maybe GitHub-based ones like Argo or Flux? So because Terraform, so because Terramate is an executable, right? It's a binary. It's basically executable by any CI/CD. So today we focused on, showing a workflow on how to do this in GitHub Actions. But you can do this in GitLab CI/CD too. You can do this in Jenkins too. You can do this in any CI/CD, right? Um, and it basically means that, so what we're trying to, the spot that we're trying to fill here is saying like, yes, the underlying infrastructure is already there, right? The infrastructure to run, so compute, async job infrastructure and whatnot is already there, and you can perfectly reuse that. But what you need is some tooling to orchestrate your Terraform modules and some tooling to basically come up with previews and those kind of things. So that's where Terramate CLI fits in. Again, which really is addable to your existing setup, yeah, in no time really. It shouldn't take longer than 5 minutes or so. And then the cloud helps you to basically observe and monitor this, collaborate on this, especially when you work with multiple repositories. Also comes with things such as the Slack notifications for failed deployments, newly detected drift, and whatnot. So what I'm trying to say is that you can basically port this to any CI/CD. Hope that answers the question. And thanks for the question too. I very much appreciate it. Awesome. So if there's nothing else, guys, as always, yeah, join our Discord. Feel free to ping me on Twitter, on LinkedIn, whatnot. Would love to help. Would love to also learn how you guys manage Terraform as of today and how you automate this kind. Yeah, would be great. So thanks for taking the time. Wishing all of you a great morning over the Bay Area, or a great evening when you're in Europe, and or middle of the night if you're in Asia. So thank you so much. Appreciate it. And I look forward to have you on the next webinar. Bye bye. Have a nice evening.